Next, we're going to look at how to divide polynomials using some other methods, mostly with long division. But we're going to look at polynomials where a is greater than 1 in the form of y equals ax squared plus bx plus c. So when a is greater than 1, we pretty much just do the same thing as we do when a is equal to 1. But let's look at an example here where we'll use some long division, and it's going to be written as a rational expression. Just means there's a fraction line that's a rational expression. So here, that first value is equal to 2 instead of 1. But the same basic rules apply. So we're going to write this as long division like this. 2x cubed minus 11x squared plus 25. Just a second here. Let me make sure everything's set up correctly. Okay. So now we're going to say how many x minus 5s go into these first two terms? And really, we just look at these first two terms. That tells us our answer. So x times 2x squared equals 2x cubed. So now we multiply that and that. So 2x squared times x is 2x cubed. 2x squared times negative 5 is minus 10x squared. Then we're going to subtract like that. This minus goes to both terms, so you can write the minus that way. Sometimes it helps students to do the parentheses, then erase them, then change that second term sign. Or you can just leave it like this. So this is 2x cubed minus 2x cubed. That's 0. 11x squared minus negative 10x squared is 11x squared plus 10x squared, which gives us negative 11 plus 10 is 1. 1x squared. We bring down the next term, which is 25. Now here's our next part that we're dividing by. We're saying x squared plus 25 divided by x minus 5. So we ask ourselves, how many x's, x times what is x squared? X times x is x squared. Now we multiply x times x and x times negative 5. That gives us x squared minus 5x. Except look what happened here. Now we have a 25 minus 5x. That's not correct. So what happened is I didn't put the placeholder 0x in place before I put the 25. So really we should have brought down a 0x. And the question should have been, how many x minus 5s go into x squared plus 0x, or just x squared? The answer is still going to be x. So we still get x squared minus 5x down here. Now when we subtract, though, our x squareds cancel. This is positive 5x plus 0x is just 5x. Now we bring this 25 down like this. Okay, how many x's go into 5x? That's just 5 x's. So that's 5 times x is 5x. 5 times negative 5 is negative 25. Now you might be thinking, oh, we have no remainder here. But if we minus, that cancels those out, but that negative goes there, and we actually are left with positive 50 for our remainder. So our remainder is plus 50 over x minus 5. So we don't just write R50, we have to write it as a fraction like that. So this is pretty much a review from the last video, from quiz number 1, where we had a remainder and we used long division. But the most important part is putting in this placeholder. If there's no x term, so it went from x squared to a constant. So we still have to put that placeholder in there. If we don't, things get really confusing. So this is our final answer for this one. Okay, let me type that in. We'll go to the next question here. And for the most part, these should all be very similar. Let me see here. Oh, let's see. Let's see what happened here. I might have gotten the wrong answer. Maybe we don't have a remainder for this one. Let me go back here and see what happened. Ah, I see what happened here. Okay. So for this one, this is supposed to be, um, this was supposed to be 5 times x gave us 5x, not -5. So this is supposed to be a +5. And so now this is a -5. And so let me go back. We're going to go back a few steps because that's going to be a little too confusing if we don't go back some more steps this way. So I'm going to go back to this first step. There's step number 1. Subtract those out. This is 0x cubed, and we're left with -10x squared, and this becomes -x squared. And then we bring down the 0x, and this is x minus 5. Now, -x squared, that should be -x. So I think I made a couple of mistakes on this one. So this one's -x. -x times x is -x squared. -x times -5 is +5x. Now we're going to subtract those. Double negative makes a positive. Our x squareds cancel out, and we're left with -5x plus 25. How many x's make -5x? That's -5 times x. -5 times x is -5x. -5 times -5 is plus 25. Now it looks like we don't have a remainder for this one. So this is -5 plus 5. That cancels. 25 minus 25 is 0. So we have no remainder for this one, actually. Okay, so these problems are a bit tedious. As you can see, if you make just one small error, then you won't get the right answer. So there's a quicker way to do this, and it's called synthetic division. Let me make sure that synthetic division is not on a different section. Okay, we're going to go over how to do this with synthetic division next. So this same problem, we should get this same answer using synthetic division. So synthetic division, we set this denominator equal to 0. Then we just add 5 to both sides. We get x equals 5. So we're going to write 5 in this box on the upper left. Now we're going to write the coefficients of the numerator on the top. 2, -11. There is a 0 for our x's, so 0 is a placeholder for the x's. And 25 is where the constants are. I'm going to put a line underneath, bring the 2 down. 2 times 5 is 10. -11 plus 10 is -1. -1 times 5 is -5. 0 minus 5 is -5. and negative 5 times 5 is negative 25. 25 plus negative 25 or 25 minus 25 gives us 0, and this is our remainder. So this was x cubed, x squared, x, and our constant. Our answer is going to be 1 lower. So this is x squared, x, constants, and the remainder. So our final answer, same answer, 2x squared minus x minus 5 is our final answer. So whenever I'm teaching long division, sometimes I'll make a small error because I'm so used to using synthetic division when we divide these. Let's look at one more of these. Okay, this next one's probably going to be easier with synthetic division. We don't have any terms that are skipping. We're going to set x equal to 0. So we get x equals x plus 3 is 0. X equals negative 3. Now we're going to write our coefficients. 2, negative 1, negative 25, negative 12. Bring down the first one, multiply by negative 3. Add those together, multiply by negative 3. Add these together, multiply by negative 3. Add these together, and that last number is our remainder. These were x cubed, x squared, x, and the constants. That means our answer has been divided by an x to the 1, so that means we're left with x squared, x, constant, and the remainder. So our final answer is 2x squared minus 7x minus 4. Okay, when we have just 1x plus something, synthetic division's really easy. If this was like a 4x plus something, it gets a little bit tougher because at the end, we have to divide again, and it becomes even more complicated. And so whenever I see something that's divided by just an x plus something or just an x minus something, I like to use synthetic division. But when I see it and it's like 5x plus something, if this number is not a 1, you can divide with synthetic division. I just steer away from it personally. So I'll still use long division for some of these. Two x squared minus 7x minus 4. Okay, so that's how to do those. Polynomials by linear expressions. And okay, so some of these are going to be written in a different form, and it's basically the same thing. It's just written differently. It says, in this polynomial, this is a factor. X minus 2 is a factor. So it means that we can divide by x minus 2 for this polynomial. So we set x minus 2 equal to 0, x equals 2, put 2 in the box, write our coefficients as long as they're in the right order. Bring down the 3. 3 times 2 is 6. 1 times 2 is 2. Negative 2 makes negative 4, and that's 0. So it's x cubed, so that's going to be x squared, x, constant, and remainder. Okay. So it says, write it as a product of linear factors. I believe it's asking us for this for our answer, but it might be asking us to divide it one more time. Okay, yes. So this is part 1. So we've divided this part out. But now we want to use the AC method. and continue to factor this. So we're breaking this down into its fully factored form. We know this is one of the factors. We know this is the second part. So far we've broken this down so it looks like this. If we multiplied that out, we would get that. But we just want to break this apart with the AC method now. So AC is -6. B is equal to 1. So this one's a little bit easier. This is 3 times -2 is the numbers that we're going to use for that one. So this is 3x squared plus 3x minus 2x minus 2. And we put a plus between there. We're going to factor this by grouping. This x minus 2 is still there. It's being multiplied by all of this. But we're just going to hang on to that for just a moment. So we're going to factor this by grouping, factor out a 3x. We're left with x plus 1. And this is x plus 1. Factor out a -2 there. So now we're left with 3x minus 2, x plus 1. And then this x minus 2, it's still there. Probably should have wrote it over up here also. So that's the fully factored form of this now. So for our answer, we're going to write this part for our answer because it already told us the x minus 2 part. Actually, let's see. It might want all 3 of them. Yes, never mind. So it does want us to put all 3 of these in for our answer. So that's our final answer. This is, if we divided this or factored all this out, this is equal to this same expression here. So those are equivalent statements. So that's what you're going to write for your answer for when it says rewrite P of X as a product of linear factors. Just to Okay. All right, let's take a look at the next problem here. We'll do one more of these with synthetic division. And again, it tells us the first factor that it's going to divide by. So this one, we're dividing by x minus 4. We set that equal to 0. X minus 4 equals 0. X is going to equal 4. So we're going to put the 4 in the box here. And 1, -6. This skips 1 when we're going in descending order. So this is a 0x plus 32. Bring the 1 down. 1 times 4 is 4. -6 plus 4 is -2 times 4 is -8. Bring the -8 down because that's just plus 0 times 4 is -32. Add those together and we get a remainder of 0. So this is x squared, x, our constant, and our remainder. So far now, when we factor this out, we have x minus 4 times x squared minus 2x minus 8. Now we want to use the AC method for this part, and we're going to write all of it as a factored expression. So AC is -8, is 1 times -8, and 1 times -8, 2 times -4, negative, let's see, 4 times -2, and 8 times -1. Okay, so it looks like those are our factors. And you don't have to do factoring by grouping if this A is equal to 1. You can just write out the answer. So this ends up just being x plus 2, x minus 4. So you don't always have to do factor by grouping with the AC method. You can just write the you can just write these numbers here like that. So then we get x minus 4. And we have two x minus 4 factor groups. So we can rewrite this as x minus 4 quantity squared and then x plus 2. So that's our final answer for this one. So we're breaking this down into two different parts. Then we can break this part down further using the AC factoring method. All right, let's make sure that's the right answer. Okay. Alrighty, so now we're going to talk about the remainder theorem. The remainder theorem is it's a way for us to sort of do what's, I guess we can call it a shortcut method when we're dividing by some information that we know. Now here's the first one, how they write it out. So we're given a polynomial and we don't know what k is. It says it's an unknown integer. So we know it's a whole number. We also know that when we divide this, whatever this is, it gives us a remainder of 2. So according to the remainder theorem, this, if we set that equal to 0, let me change this. Let me zoom in a little bit and fix the pen here. Just a second. So if we set x plus 1 equal that to 0, why this isn't changing, me just trying to change this so you can see this a little better. So x plus 1 equals 0, x equals -1. That tells us that p of -1 is equal to 2. So when we plug in this value for x and we get a number, that number is our remainder. And that's what the remainder theorem tells us. So we can use this quantity to find what k is. So now we can plug in -1 for x on all of these. And when we plug in -1 for x, we set all of this equal to 2, which is our given remainder. And this is more of like really, I guess, a theoretical question because many times we don't really know the remainder. But here they tell us the remainder and they tell us what it's divided by. We have to find the missing value. So we're going to plug in 2 for, or -1 for all of our x's. So 2 to -1 to the 4th minus -1 to the 3rd plus 2 times -1 squared minus k. And we're going to set all that equal to our remainder, which is 2. Okay, now when you do this in a calculator, anything with an even power, if it's negative, becomes a positive. So this is actually 2 times +1 minus, and if it's an odd power, it stays negative. So minus -1 is +1 plus 2 times, there's another even power, -1 times -1, or -1 squared is +1 minus k equals 2. So now this is 2 plus 1 plus 2 minus k equals 2. Pretty simple from here. 5 minus k equals 2. Bring the k over. 5 equals k plus 2. K equals 3. So that's our missing value using the remainder theorem. Okay, let me see if there's any that are in a different form. Yeah, so there's some questions that are given to us in graphical form. So it'll say this polynomial is on the graph, and we have to find what the remainder is. So it says p of x is divided by x plus 1. What's the remainder when it's divided? So for this one, we just look at the graph. We're going to set x plus 1 equal to 0, because that's what it's being divided by. So x equals -1. And so we want to find p of -1 is going to tell us the remainder. And so if this function is p, we're going to plug in -1 for x, and that's going to tell us what that corresponding value is for p. So we go to -1 on the x. Up here is 3. And so that's just our remainder is 3. We just so happen to get 3 again for our answer. This is a totally different problem, but our remainder is 3 again. So again, we set that equal to 0, plug it in for x, and find our corresponding y value, and that's what our remainder is going to be. If we don't have a remainder, it should cross the x-axis exactly. And so that's why when we have things in factored form, like I'm just going to make something up here. If we had something like that in factored form, let's say there's something else even like that. So these would be the zeros of our polynomial. So our polynomial would cross at x equals 1, x equals -2, and x equals -5. So if we had something that was factored like that, we'd get a graph, and it can do all kinds of things in between, but it crosses at these values where they equal 0. So that's just a little more background about what these graphs are doing with the remainder. So when we have a 0 remainder, when everything's perfectly factored and we don't have anything extra, like we do the AC method and we get a nice clean answer, our answers are going to be right on the x-axis. But here, our remainders are going to be somewhere else. Okay, we're going to look at one more remainder problem. This next one gives us a list of information, and we have to decide from that list what the correct answer is. So it says p of x is a polynomial, and it gives us all this information here, and we have to choose what the right form of the information is. So it says p of 4 equals what? So p of 4, we have to decide, are we going to use x minus 4 or x plus 4? We're given the remainders of all of these when we divide by them, which is kind of nice. Further along in pre-calculus, we have to find out how to determine what we're going to divide by so that we don't have a remainder. But here it just gives us a list of everything. So p of 4, that's x minus 4. Because if we did x minus 4 equals 0, we'd get x equals 4, and then we would do p of 4 to find that remainder. So the first one's going to be 7. And p of -9, we're going to use the positive 9. And that's -5. So these aren't too bad. We just have to conceptually determine which information we're going to use here. Okay, and there's one more that's giving us sort of the same thing, but it's in a table value or table format. So this says, here's the polynomial, here's some values. What's the remainder of this polynomial when we divide it by x minus 6? Well, if we divide by x minus 6, we set x equal to 0, and we find the remainder of when x is equal to 6, not when x is equal to -6. So not that one. When x equals 6, it's -5. What's the remainder when p of x is divided by x plus 4? That one's going to be when x is -4, which is going to be -1. Okay, so we'll type those in here. 5. Okay, the next one is finding the factors with the remainder theorem. This one's very similar, but this time we're missing some different information. So before we were trying to find what k was, now we want to find what c is, which is the coefficient of our x squared term in this polynomial p of x. So it says if we divide this by x plus 2, we get this answer here. So if we set the x plus 2 equal to 0, You get x equals -2. Now we can say p of -2 equals, and um, we're going to put in -2 for all of this. Um, It says so that it is divisible by x plus 2. Okay, so this is some key information, the way that it's phrased, so that it is divisible by. That means there's no remainder. So when there's no remainder, we're going to set p of -2 equal to 0. So we're going to write all of this like this. 4 times -2 cubed plus c times -2 squared plus -2 plus 2, all equal to 0. Because we're saying that this polynomial, when we divide by x plus 2, that we get no remainder. That means that this should equal 0, which means that when we divide by x plus 2, this is on our x-axis at x equals -2. It crosses exactly at -2, whatever that function ends up looking like. All right, so now we're just going to multiply this out. This is +4, and that equals 0. Those 2's cancel. We're left with -32 plus 4c equals 0. 4c equals 32. Divide by 4 on both sides, and we get c equals 8. Okay, so that's just some way that we can phrase this, is that if it's not divisible, it has no remainder. Okay, so here's another one. It says select all these polynomials that have x plus 2 as a factor. So this one, you could divide all of these by x plus 2 and see it gives you um, if it gives you an answer without a remainder, or the shortcut method is using the remainder theorem. So if we solve this, x plus 2 equals 0, x equals -2. Now we're going to find, we're going to plug that in for x, and it should give us 0 as a remainder. And if it gives us 0 as a remainder, that means x plus 2 is a factor of the polynomial. So you have to still check all 4 of these, but we have a lot less work to do, because now all we have to do is plug this in for x. So for a, we get -8 minus 3 times 4 plus 20, -8 minus 12 plus 20, -20 plus 20. For that one, we do get 0. So if we divide that by x plus 2, we'll get a remainder of 0. So that one checks out. Now we're going to check B, C, and D, do the same thing. Okay, so we're going to say B of -2 equals -2 cubed plus 5 times -2 squared plus 4 times -2. Okay, we get -16 plus 20. Looks like we get +4, so not B. Not B. Try C and D next. So we're going to plug in C of -2, -2 cubed, minus 2 times -2 squared, minus 13 times -2, minus 10. It's -8 minus 8 plus 26 minus 10. Negative 16 minus 10 plus 26. Negative 26 plus 26 gives us 0. So C checks out. If we divide that by x plus 2, we should get a remainder of 0. And you can check all these with synthetic division as well if you wanted to. So you could, let's check D with synthetic division. Since we've kind of got the remainder theorem figured out now, we've done 3 of these so far. Let's check D using a different method. So if we put negative 2 here in the box, 1, negative 6, 11, negative 6, we're checking to see if our remainder is 0. And we're just going to solve it, which I guess takes a little bit more time, but synthetic division is pretty fast. So we get negative 2, negative 8, positive 16, 27, negative 2 times 27. Negative 2 times 27 is negative 54. Add those together, we get a remainder of negative 60. So we get negative 60, and that's not 0. So our final answers are A and C. So now you can see 2 different ways to solve these. You can use synthetic division, or you can just plug it in using the remainder theorem and see if it makes a true statement, see if it equals 0 for a 0 remainder. Okay, and that's everything from Unit 4, Quiz 2 on polynomial division.